I'm Michael Buser, National Program Leader for Engineering at the USDA Agricultural Research Service. I also serve as the National Lead for a fairly new national initiative called Partnerships for Data Innovations, or PDI. Whether our research data are in green lab journals, binders, or Excel spreadsheets, there is no hiding from the fact that conducting research today requires an ever-ending volume of data. Not just expanding data, but data volumes that grow exponentially from megabytes to gigabytes to terabytes to petabytes. Because of this volume of data, we are able to conduct much more complex and integrated analysis, typically via multidisciplinary or transdisciplinary teams across numerous research locations. This is a new way of conducting research that is incredibly powerful. But I don't have to tell any of you that there are bottlenecks everywhere in the system, and navigating around these obstacles takes your time, tests your patience, and often limits your productivity and impact. I'm certain if you collect, manage, or move data, you have probably bumped up against some of these roadblocks. Data silos keep you from sharing or accessing data. Transferring data from notebooks can lead to numbers being transposed, or results in other data anomalies. Once we get data into a digital form, we save it, and then we save it again and again, creating inefficiencies in the movement and storage of information. Terabytes of valuable legacy data are hidden in binders on isolated bookshelves. When we send our samples out for external analysis, we give up control, potentially introducing additional inconsistencies. But that problem is not only with external labs. Often our internal lab procedures are not consistent either. And often our procedures require technicians to touch a single sample dozens of times throughout the process, resulting in operational and analytical inefficiencies. The USDA PDI initiative is focused on identifying or developing innovative data management solutions that can be deployed and maintained on a national scale. A year ago, we launched a data management streaming effort called Partnerships for Data Innovations, or PDI. PDI was developed because agricultural researchers and our industry stakeholders have questions like, why don't we standardize our data collection methods? Why don't we integrate our data in a cloud platform? Why don't we integrate our agricultural production and conservation management tools and outreach materials in a common cloud platform? Why aren't we using more automated data collection, processing, storing, and distribution methods? Our agricultural research communities are asking for solutions to address these issues so we can move agricultural research forward at a much more rapid pace. Our stakeholders are asking that we develop these types of systems so they can easily find trustworthy data, decision support tools, and educational materials to help them be more productive while preserving our natural resources. Through PDI, we are working to innovate the way we collect, handle, process, store, analyze, and share data in this big data world. The effort has resulted in launching a new online workspace for sharing and interacting with multiple data sets. The Agricultural Collaborative Research Outcomes System, or AgCross, is envisioned as a one-stop shop where you can find and share data that are standardized and interoperable. AgCross provides a key way for you to collaborate with other scientists, gather data, and utilize high-performance computing resources. Finally, the PDI effort leverages the power of public-private partnerships, bringing shared tools and resources together to maximize our research relevance and impact. If the PDI initiative is successful, we will leverage the power of network computing and public-private partnerships to create customized solutions that reduce the time our researchers spend on data management, so they can spend more time on their science. The project is aimed at increasing the efficiency of data handling through innovation that will improve the way we collect, process, and analyze our data, automation that will decrease data and sample touches through improved processing efficiencies, Standardization that ensures our data are high quality and interoperable with other data sets, and integration to expand the power of data sets and increases the opportunities for collaboration. By achieving these goals, we can create a living, working data environment that will enhance research across all our research institutions and organizations. We can develop tools, models, and decision support technologies that are more interconnected and more easily updated and maintained. The working data environment will serve as a multi-location, multidisciplinary network that leverages new platforms to greatly increase the impact of our research for our colleagues, collaborators, private partners, and the American farmers and ranchers. These are lofty goals, and they're not going to be achieved overnight or on an island. To achieve these goals, we're going to have to work as a community. In addition, we need the solutions today, not 5 or 10 years from now. The PDI leadership has set some lofty goals in short timelines that will only be achieved through collaborations and partnerships. As I previously stated, the PDI initiative was officially started in June of 2019. And since then, the initiative has been highlighted at 4 high-profile events. The ARS, Office of National Programs, hosted a by-invitation-only event on October 7, 2019 to introduce PDI to the leadership of various USDA agencies. On October 8, 2019, Microsoft CEO highlighted the PDI initiative in his opening talk at the 2019 Government Leaders Summit in Washington, D.C. In February of 2020, PDI was the feature plenary presentation at the Esri Federal GIS Conference in Washington, D.C. On July 13, 2020, PDI received a Special Achievement in GIS Award from Esri at the Virtual Users Conference. To me, the number one question for any project is, who are the stakeholders? Who are the customers? To me, the PDI target customers are clear. Our number one customer is our in-house research teams. Our number 2 target customers are collaborators. Nearly all of our ARS research units work with collaborators. So if the PDI solutions do not work for these collaborators, then the solutions do not work for our ARS researchers. Number 3 are stakeholders and customers linked to our research institutions. And finally, our responsibility back to ARS and the USDA administration. PDI is actively working with ARS researchers from about 28 of our 90 research locations across the United States. We are working with several universities, other federal agencies, state agencies, and private industry. On this slide, I have highlighted a few of the groups that we are actively working with. As we progress through year 2 of this initiative, our number of collaborators and partnerships will continue to expand. Although this is a national initiative being led by ARS at a national level, it is very much a grassroots effort. There are no proposal requirements to join PDI, and there are no formal invitation lists. Getting involved with PDI is fairly straightforward. Send an email to pdi@usda.gov, provide a short description of how you would like to work with PDI, and we'll schedule a call to discuss next steps. I will warn you that it will likely take us a few weeks to get back to you, as we are currently engaging and starting new collaborations with a large number of researchers. With that said, we will be in touch if you send us an email. Unfortunately, I don't have enough time to dive deep into the schematic, so I'll discuss it at a high level. Items in the green boxes represent data management solutions that PDI is actively working on today. These include expansion of the AgCross data platform, developing linkages to external data platforms such as Ag Data Commons, NOAA, USGS, and others, developing customized data collection apps for observational data, evaluating connectivity solutions to improve the transmission of data from field to the cloud, developing linkages between continuous monitoring systems and AgCross, developing optimized regional laboratories for common sample analysis. The boxes in the red are things to come. We will likely start on some of these in 2020. The Decision Support Informatics Platform, or DSI platform, is something that I'm excited about, and I'll touch on briefly in a few minutes. We have Microsoft TV Whitespace technology installed at our Beltsville, Maryland location. Our current goals are to conduct a spectrum evaluation at 5 additional ARS sites, hopefully later this summer. Once we have this information, we will be working with Microsoft and Verizon to develop concepts to solve some of our data communication issues. In January of 2020, PDI began an effort to develop an SOP for UAV research. Our goals were to standardize how we collect our pre-flight information, conduct our flights, process our data, and share and publish our results. A key part of this effort was to identify the software components that would be used in the SOP. From a national perspective, we were interested in software solutions that will work for the majority of our researchers, as this will help us with procurement and long-term software maintenance strategies. Originally, this started out as an ARS effort for our long-term agroecosystems research, or LTAR network. Since then, this effort has expanded to include researchers outside of LTAR, including NRCS and state conservation services. The software that we are currently evaluating is called SiteScan. It is an Esri product. The video that is playing is highlighting some of the SiteScan features. We are currently evaluating the software at 5 ARS locations. At these locations, the pilots and the researchers are critically evaluating the software and developing a list of pros and cons and issues related to the software. One of the great things about the PDI public-private partnerships is how these partnerships are currently functioning. For example, we are sharing the pilot and researcher feedback on SiteScan with Esri. Esri has been highly responsive in addressing this feedback. They've even made software updates based on some of this input. The value in the ARS, NRCS, and State Conservation Service collaborations in this specific effort is developing a more robust SOP that can be used by multiple agencies. Further, if we are using the same SOP and sharing data, we can minimize future duplicative efforts by working together and conducting collaborative UAV missions. We are developing a PDI regional manure plant soil and water laboratory at University Park, Pennsylvania. ARS has made a large investment in this laboratory to optimize the sample analysis process by eliminating equipment bottlenecks, minimizing sample handling, and developing software to minimize data touches. Our goals are to increase the capacity of this laboratory by about 10-fold. When fully operational, this laboratory will be a huge resource for the LTAR network and others within ARS seeking common manure plant soil and water analysis. We are developing customized tools to capture field management data. This data is stored on the cloud and is available to local users with permissions. PDI has developed customized apps for citrus production, which are being used by researchers, APHIS inspectors, producers, and funding agency staff. We are also developing a customized field management data collection apps. The goals of these apps are to more accurately capture the management activities that occur on our research fields, make this data available to our researchers or research community instantaneously, assuming that we have connectivity, and digitally preserving this information. Next, I'll show you a quick video of the citrus production app. Through this video, I hope to give you a quick feel for the data input apps that PDI is developing. They are customized apps for targeted end user groups. For this specific app, the target end users are citrus producers and APHIS personnel. The PDI tech team worked with the end users to develop a list of field management data that was needed to be collected and then developed a draft data flow layout. The tech team developed a beta version of the app, which was used in follow-up discussions with the end users. Then the end users and the tech team had weekly calls to fine-tune the app. Once the end users were happy with the app, it was published and ready for use. Typically, this process takes a month to 3 months, depending on the end user group. The app that is being shown in this video came out of a brief discussion at the 2020 Beltwide Cotton Conference. For years, the cotton research community and industry had been talking about integrating data sets from dirt to shirt. Most of these discussions were focused on integrating data sets that had already been collected. Discussions at the conference between Chris Delholm, Ed Barnes, and myself led to the Dirt to Shirt data initiative within PDI. Chris and Ed rapidly pulled together researchers that saw the need for integrated data management systems and researchers that were eager to participate. By April, Chris and Ed had pulled together 3 groups of researchers in the areas of plant breeding, agronomics, and post-harvest. By the end of April, the PDI technology team had developed a beta version of the data collection app for cotton researchers. During the month of May, this app was modified numerous times. Although the development of this app has been slowed because researchers are in the field, and the PDI technology team has been temporarily assigned to helping develop COVID-19 laboratory reentry digital tools. This research community led by Chris Delholm has made considerable progress in less than 3 months, and we should have no issues rolling out the app this fall, which should provide ample time to release the app to the cotton research community and provide training. Now let's go one step further and talk about data visualization and QA/QC of observational data. A core value of PDI is giving credit where credit is due. In this video, we're looking at a story map of an organic amendments project out of Fort Collins, Colorado. Once we have research data in AgCross, our researchers want to visualize the data and inspect the data for possible errors. To do this, we use customized insight dashboards. We have the ability to develop dashboards to meet a wide range of our researchers' needs. For example, in this interactive dashboard with drill down capabilities, the researcher notices a potential data error. If the researcher has permissions, they can enter into the N2O dashboard that has a Survey 123 app embedded within the dashboard. The researcher can highlight the replication with the error, scroll down to the measurement parameter with the error, and make correction, and then submit the update. The change is logged in AgCross along with a date, time, and user identified with the change. These dashboards are fairly easy to create. The challenge is figuring out exactly what a research community or a group of researchers wants to visualize. In this video, we are going through the AgCross interface to a specific research project in Beltsville, Maryland. In this project, we are overlaying Venus satellite, AgVoice, unmanned ground vehicle, and continuous monitoring data. Here we are going to zoom into the scientist observational data collected through the AgVoice technology. Now we are looking at some real-time soil moisture data being relayed through Microsoft FarmBeats platform. We also provide the ability to bring the data from equipment-mounted sensors. All of this information is brought into a geospatial platform in separate data layers. Using the AgCross platform, we link to external sources such as Venus satellite data, where we are overlaying Venus NDVI data. PDI's role in this process was to help the scientists develop the data management solutions to standardize, integrate, and automate their data collection so they could focus on refining the machine learning models and their other science objectives. The AgCross environment provides us the ability to connect multiple networks for a given specific metric. We can locate all available data sets for a metric of interest by selecting the cross-site graph function and selecting the metric. Here we're selecting nitrous oxide. What looks like a simple graph is really not that simple. This graph of average nitrous oxide emissions is an example of scientist contributions integrated across 30 different sites and multiple networks. As a result, our researchers can spend less time looking for and compiling unconnected data sources and spend more time on exploring and analyzing those data sets to address our mission-critical agricultural issues. An exciting upcoming AgCross capability will allow users a one-stop shopping experience to retrieve related data housed in other government websites. Here's a simple example of browsing through weather-related data from NOAA called MADIS, along with NASA imagery and satellite data. By clicking on the points in the map, you can see live weather station data. Looking at the left-hand side of the screen, you can see many available data layers. So let's zoom into a simple example of grabbing data from multiple layers. We see imagery for North Carolina covered by weather data along with point data from weather stations. Using our data discovery tool, we can select an area of interest to get all of the data layers shown. Although it is not shown here, you can turn layers on and off based on your interest area. Once the area of interest is chosen, you can select the data products that you like, just like shopping online. Simply add images and tabular data to your shopping cart, and then it can be downloaded. Here is all the weather station data in a spreadsheet. Or you can download image data shown here at the latest NASA MODIS satellite imagery. Keep in mind, we are not storing other agencies' data, just retrieving it. While this feature is not yet active, we envision AgCross as a portal for the agricultural research community, saving our researchers time and providing direct links to multiple data sources in a single platform. This slide is messy, but I wanted to make the point that our agricultural researchers develop a large number of models, decision support tools, outreach materials, and other products. The challenge is that it can be extremely difficult for our stakeholders to find these outstanding resources. The goal of the Decision Support Informatics Platform, or DSI platform, is to create a one-stop shop for stakeholders to find our researchers and the incredible products they are developing. This will not be an easy task. We'll lean heavily on our private partners such as Esri and Microsoft to help us develop these customized solutions. Imagine our stakeholders having a single platform that they could visit to get information. For example, say we have a stakeholder that is interested in locating reservoir or water resource experts. They could click on the expert icon on the DSI platform, search for reservoirs and water resources, and they could see a list of experts from ARS, universities, and other government agencies. Let's go one step further. Imagine our stakeholders interested in earthen dams to have the ability to go into a single platform, click on the Decision Support Tools icon, enter the search term dams, and have access to the publicly available decision support tools for dams. I know I've heard from numerous research stakeholders that they would like to see a common platform like DSI developed. And finally, what if you could search the DSI platform and locate training or field days that you're interested in? At this point, the DSI platform is an idea. Developing a platform like this will take the expertise of many, and we will need the expertise of many more to help us figure out how to maintain a dynamic system like this for the long term. In the fall of 2020, we will move the effort from an idea phase to a conceptualization and design phase. If you have ideas or want to be involved in this endeavor, please send us an email at pdi@usda.gov. The PDI organizational structure broke down into 5 major components. First, we have the PDI board, and I will introduce them shortly. All data management tasks submitted to PDI will be evaluated by the board. If approved, the board will assign the task to a task bucket and will assign a priority rating before submitting the task to the PDI technology team. So what are the task buckets? These task buckets include aligning and integrating historical or legacy data sets, working with continuous monitoring systems, developing observational data input apps, developing data dashboards, and other. The other task bucket could be things like developing customized software solutions to automate data collection from things like balances, or developing specific APIs. Next, we have project coordinators. These coordinators work directly with the researchers. Typically, when a data management task is identified, a project coordinator will develop a work request. This request will include a general description of the data management task, a data frontline manager, a group of scientists who are experts in this area and have interest in this task, and a few other task-specific questions. This work request is then submitted to the PDI board. If approved, the research committee will be formed and called to order under the guidance of the data manager, under the guidance of a project coordinator. For the majority of these committees, we are hoping to complete the committee work in less than 3 months. Now, this is highly dependent on the committee and the PDI team workload. These committees will be charged with refining the criteria for the data management products. Once the initial criteria are established, this becomes an iterative process where the PDI tech team develops a solution based on the committee's criteria. The committee evaluates the solutions and provides feedback. The tech team will then rework the solution based on the new feedback. This process continues until the committee is satisfied with the tech team's solution. At this point, the solution is released and the committee is dissolved. Next, we have the PDI technology team. These are the dedicated developers for PDI. This is where the solutions are developed. Then we have the PDI Regional Labs effort. Currently, we are developing a pilot regional manure plant soil water laboratory focused on common sample analysis. I touched on that earlier in my presentation. Next, we have the project assurance team. This team has not been formed yet, but we are hoping to do so in the near future. The goal for this team is to evaluate all the products that we are developing to determine whether or not what the economic benefit is or benefit to science is. The board includes Darren Harmel, Jim Eppolito, Jayoung Sun, Marlon Eve, Pete Kleiman, Sarah Bebelt, and myself. This is just a glimpse of the PDI initiative. We understand that there are many real-world challenges that researchers face every day related to data. PDI is interested in learning about these challenges and working with you to create tools to solve these challenges. At the end of the day, PDI is interested in developing solutions to decrease the time researchers are spending on data management so they can spend more time on research. The PDI team has a vision. It is not a vision for IT or computer programming. It's not even a vision for data management. It is a vision of producers and consumers benefiting from expanded research and data collaborations. It is enabling collaborative research and precision agricultural management through data innovation, automation, standardization, and integration. Succeeding in our vision will benefit researchers, ARS, our collaborators, our public and private partners, and most importantly, our farmers, ranchers, and land managers. Succeeding will help fulfill Secretary Perdue's vision to do right and feed everyone. If what you have seen today has inspired you to think differently about your data, how to collect it, process it, share it, and communicate it, then I would invite you to reach out to the PDI team and let us know what you're thinking and how we can help.